Hey guys, so we're moving from direct variations to inverse variations, but you'll notice we're still going to talk about direct variations later on in this video. So this right here, this meme, not really that true, because if you are putting substantial effort into memorizing something, you should be good, but the probability of remembering something is inversely proportional to the amount of effort you put into remembering it. It feels that way sometimes, especially if you're just trying to use straight memorization and you're not trying to actually learn. There is a difference. If you need me to give me an example, ask me in class. Let's start with definition. All right, when y varies inversely as x, that means as one factor increases, the other decreases. So as x goes up, y goes down, or vice versa. And when we say that, it's the absolute values of the numbers that act that way. With regard to things like negatives, it does act a little bit funkier, but generally what you see here, as x increases, y decreases. The product of x and y is what stays constant. The product of them is what stays constant. In fact, that product is equal to the constant of variation, and we'll talk about that in a second. An inverse variation is described by the equation y equals k over x. And that should make sense, because the bigger this denominator is, as this k stays the same, the bigger this denominator is, the smaller the fraction actually is. 1/2, 1/3, 1/4, 1/5, 1/6, 1/7. Those fractions are getting smaller. If you're getting a 1/12 of a pizza, you're not as happy as if you're getting a 1/6 of a pizza, if you feel the same way about pizza that I do. Anyway, let's look at this equation real quick for that constant of variation right there. If you take my equation that I've got written down right here and you solve it for k, what does that mean? Well, if we have y equals k over x, if we multiply both sides by x, it cancels out on the right, and we get xy is equal to k. And that is the same relationship as y equals k over x. xy equals k is the same relationship as y equals k over x. And what's happening here is that product is constant. That product is the constant of variation. Let's try one. Suppose y varies inversely with x and y equals 8 when x equals 3. What is the equation for the inverse variation? Well, start with your formula. Y equals k over x, or xy equals k. Now, if you have a problem like this where you're given x and y, but you're not given k, you're going to use this formula. You want this one. But if you're given k and one or the other value, you're going to go ahead and use this version. And in reality, guys, it doesn't matter which one you use, because the equation describes the relationship, whether it's the first one or the second one. No matter what, this equation, or these two equations, will describe an inverse variation relationship. We're going to use the one on the right, though. So we're going to plug in our x and our y and get the value of k. And our x is 8, or excuse me, our x is not 8, our x is 3. Our x is 3 when our y is 8. Multiply them, we get 24. The constant of variation is 24. So to write your answer for the problem, write y equals the constant of variation over x. And this is the equation for that inverse variation. You try one. Suppose y varies inversely with x and y equals 9 when x equals 6. What is the equation of the inverse variation? Okay, sorry, I had a quick interruption there. Hopefully you are ready to pause your video and try it yourself. I'll get you started. All right, hopefully you've done it yourself and now you're just watching the result. Plug in the x and the y. Find k. So 54 is k, and that means y equals 54 over x. And let's double check it. Let's make sure. If I put a 6 in there, 54 divided by 6 is 9. Yes, it is. What's another ordered pair that would match? What if I put 2 in there for x? What would the y be? Why don't you find that out? You can tell me in class. Let's move on to an application problem. Okay, so here's an application problem for you. The weight needed to balance a lever varies inversely with the distance from the fulcrum to the weight. Now we're going to use that verbiage because that's going to help us write a formula for this. The weight W needed to balance the lever varies inversely with the distance D. So the weight varies inversely with the distance. If I go to solve that for k, I have w times d. That's how we rearrange it. Multiply both sides by w, w times d. So when you have a problem like this where you have two sets of numbers, here we have weight 1 and distance 1, which is going to be our x, and weight 2, which is our 1,000-pound elephant, and distance 2, which is our 7 feet. What we can do here is, because this k is the constant, we can say the first weight times the first distance equals the second weight times the second distance. And it's a really easy little equation to use because I can put my 160 in for the weight of the dude and x for his distance equals 1,000 pounds for the elephant times the 7 feet distance from the fulcrum. Now I just have to solve my equation. 160x equals 7,000. Divide by 160 on each side. That means that the distance x that you see there is equal to 43.75. And yeah, I totally cheated and used a calculator. Sorry, you'll get over it. 43.75 feet. So that guy has to be, this guy over here has to be 43 and 3/4, 75 hundredths, or 43 and 3/4 feet away from that fulcrum when the elephant here is only 7 feet from the fulcrum. Okay, you try one. Okay, so for this one, you should be trying this on your own. 120-pound weight is placed 5 feet from the fulcrum. How far should the 80-pound weight be placed to balance the lever? And again, we already know that the weight times the distance is what remains constant because the weight varies inversely with the distance. And yes, I wrote it as I said it because that's the best way to do this. The weight varies inversely with the distance. Try this one. All right, if you didn't pause it and try it, go back and do that. It's the same idea as the previous problem because the weight times the distance is what remains constant. So if I have 120 pounds, 5 feet from the fulcrum, 80 pounds would have to be, I don't know how many feet from the fulcrum. You could use d or x at that point right there. So that's 600 equals 80d. Now before we go ahead and find it, let's think about the concept here so we have an idea of what our answer should look like. 120 pounds is 5 feet away. If it's lighter, it should be further away. Okay, heavier was closer, lighter, further away. So let's go ahead and solve it by dividing by 80. 600 divided by 80, well, it's 60 now divided by 8, so that's 30 over 4. That's 15 over 2, or 7.5. So that distance for that other weight would be 7.5 feet. Alrighty, direct or inverse, this is our next step here. Is it a direct variation or an inverse variation? Don't be bothered by the numbering jump. We're just not going to do example 3 in the notes. We're going to look at it in class. So we're going to say here, do the data in the table represent a direct variation or an inverse variation? Well, for a direct variation, remember what stays constant. For a direct variation, it's the ratio of y to x that stays constant. So k is equal to y over x. So that's what you're going to look at. Is that ratio constant? Then it is direct. For inverse, you're going to look at the product of x and y staying constant. The product of x and y. So if that's constant, it's inverse. If neither of those things are true, then it's neither. And in this case, one is direct, one is inverse. Let's try it out. So what we're going to do each time is first we're going to test out the ratio of y to x. Negative 15 divided by 3, that's negative 5. Is that the same as negative 20 divided by 4? Yep, negative 5. As negative 25 divided by 5? Yep, negative 5. They are all equal. This is a direct variation. Okay, direct variation. That means now I can write the equation. Well, here's the cool part. What is the ratio of y to x? That's k. So if I go back and I look at my direct variation stuff, it's y equals k times x. So I'm just going to plug in the negative 5. So y equals negative 5x. And that's my equation for a direct variation. And in this case, it is direct. There's my equation. So direct variation, there's my equation. So the next one, I didn't even have to look at inverse for this one because I confirmed it was direct. So the next one we're going to try out first, is it direct? So let's try y divided by x for each one. 9 divided by 2, 4.5. 4.5 divided by 4, 1.125, I think. So that's definitely not equal. So it is not a direct variation at all. Well, is it an inverse variation? Well, let's find out. Does k equal x times y? Well, the first one is 2 times 9. That's 18. Okay. Does that equal 4 times 4.5? 4 fours is 16. Half of 4 is 2, so that's 18. Hey, check it out. So far, we're good. Let's try the last one. 6 times 3. Yep, that's 18 as well. It is indeed an inverse variation. Now, again, there is no going back and trying to figure. You already know your constant of variation. It was the constant product you found. So y equals k over x, or y equals 18 over x. So it was an inverse variation, and there's my equation. So sometimes it'll be direct, sometimes it'll be inverse, sometimes it'll be neither. Sometimes it'll be neither. All right, so you look, direct or inverse, and write an equation for each one. I'm going to ask you to pause it and try it, and then I'll go ahead and write it out. All right, so for direct, I started to write it wrong. For direct, it's going to be y equals k times x. For inverse, it's going to be y equals k over x. And remember what that means. That means k equals, oops, I'm messing up my colors again. Sorry, guys. That means for this one, k equals y over x. And for this one, k equals xy. So test it out for each one. Let's do inverse first. Negative 12, or direct first, excuse me. Negative 12 over 4, negative 3. Negative 18 over 6, negative 3. Negative 24 over 8, negative 3. Definitely a direct variation. Y equals k times x. Y equals negative 3x. All right, try the other one. Negative 12 over 4, negative 3. Negative 8 over 6, negative 4/3. Clearly they are not equal. It is not a direct variation. Now I'm going to test out inverse. 4 times negative 12, negative 48. 6 times negative 8, negative 48. 8 times negative 6, negative 48. It is indeed an inverse variation. Y equals constant of variation over x. And there you have it. Again, we could have direct, inverse, or neither on the ones we look at later on in class. How about just a situation? Okay, let's look at each of these. Does it represent a direct variation or an inverse variation? Explain your reasoning. The cost of a $120 boat rental is split among several friends. All right, so to answer these, you're going to find it helpful sometimes to make a table of values, and sometimes you're just going to be able to puzzle it out. I'm going to make a table of values because I think that's a little easier with the boat. If one person, so X is the number of friends and Y is the cost per person. If one person rents it, it's $120. If two people rent the boat, it's only $60 per person. If 3 people rent the boat, it's only $40 per person, because then it adds up to the total that you need, which is $120. Well, as you look through the table, X is going up, Y is going down. This is an inverse variation because you're splitting it between the 3 of you, okay, or the number of people, however many of you there are. The other one, you download several movies for $14.99 each. Gosh, those are expensive movies. Don't download those. Make sure you get permission first. Cost per download times the number of movies equals the total cost. And so the total cost, which they're showing you here, is the total cost divided by the number of movies downloaded. That's what stays constant. So again, we could make a table for this one as well. If X is number of movies rented and Y is the total cost. 2 movies. Let's see, 2 $15 movies would be $30, so $30 minus 2 cents, $28.98. 3 movies would be 3 15s would be 45, so minus 3 pennies, so $44.97, and so on. As these X's are increasing, these Y's are increasing, this is definitely a direct variation. Okay, and I know the information is here as well in the answer, but I figured I would write out a little table for you. How about you try with your own 2 situations? Does each situation represent a direct or an inverse variation? A, you buy sweaters in a clothing store for $35 each. Or B, you walk 5 miles each day. Your speed and time walking vary each day. All right. Pause it and think about it. All right, so for A, 1 sweater is $35. 2 sweaters would be $70. Gosh, those are expensive sweaters. 3 sweaters would be $105 for 3 sweaters. No thanks. But that's clearly a direct variation because as the number of sweaters is increasing, so does the cost of the sweaters. What about B? If you walk, so it's 5 miles each day, right? So if you walk at 1 mile per hour, okay, so speed and the time, okay, which actually it probably would be the other way around, but if you walk at 1 mile per hour, it's going to take you 5 hours. If you walk 2 miles per hour, it's going to take you 2.5 hours. If you walk at 5 miles per hour, it's going to take you 1 hour. And you can clearly see that as your speed is increasing, your time is decreasing, and that is an inverse variation. Inversely varies with each other. So this is not the easiest concept. This is a new one. I know most of what you've seen so far has been review, but we're really finally reaching the stuff that's totally new. So be able to give me some examples of each, what varies directly and varies inversely. We'll do a fun little activity with this in our last couple days before Thanksgiving. I'm pretty excited about Turkey Day myself. Hopefully you are too. All right, guys, make sure you took good notes. I'll see you in class.